All right, so this is the first, it's about 10:50, right, almost 11. This is today's physics work that I did. Took about like an hour and a little bit. So, yeah, there's that. Yeah, okay. So let's go over this. So, got a ball thrown up at 20 meters per second. And then there's a couple of problems. So first of all, sketch these graphs. Well, we already know the acceleration always because we're going to assume that it's being acted on by gravity. So it's always negative 10 meters per second. We assume that this is down, like going that way. And then our initial velocity, as you can see here, is 20. So we can, it starts above the x-axis here. And then so it reaches v equals 0 at this point, as you can see, and that's actually when, as you can see here, this is kind of like its height in a way. So at here, it reaches its absolute its maximum, and here the height or the velocity is 0. And then it starts to decrease. So it's positive here, 0, and then it starts to decrease. So just some kind of like calculus intuition there. So what is the maximum height of the ball? We know this. If you take the integral, then you get of acceleration, you get velocity. So here we use the integral power rule. We get that, and then yeah. So initial velocity is equal to 20. Then that's where this comes from. And then we're gonna position is a second integral, or just the first or second integral of acceleration, or the first integral of velocity. So here we go. You can see that, and then we're gonna say that equals 0. Then it just equals the x position, or the initial position. So got that. And then this is just how to find the what's it called, the maximum, the x value for the maximum, h max. Okay, and then here, yeah. So here, that's, hold on. See, I'm using this. I'm using the x or not. Okay, it's not. I say x because this is the x-axis, but in this case, it's really precisely it's really the t, because it's t versus x. My bad. So here we have the h max equals 1/2 of a. Just using the formula that we got before, and then we're substituting in t. So here, get this, and then now algebra. We get negative velocity squared over 2a. That's h max, and then get 20. And then this was just another way, but my physics teacher, he didn't really tell me how to prove this, so I just put it on there anyway. But I don't know, maybe I'll prove this in the future. We'll see. So alternatively, we got this as well. So the initial position, or sorry, not the initial position, the initial kinetic energy initial, and the potential energy initially. So these are the energy initial and energy final. So here, initial kinetic energy is at right, now where is it? Yeah, right here. So here, got it's 1/2 mv squared, and rv is just our initial velocity, and then we have no potential energy because well, h is 0 and it's mgh, so that's 0. And here velocity is equal to 0, so this is also 0. And then here mg h max, because it's at it's right here. So we're gonna combine these together, and then we have this. So the m, actually they cancel out, and then do some algebra here. So h max equals 1/2 v squared, or v naught squared over g. And as I said, those cancel out. So we have h max equals v naught squared over g. So here, into like a slightly different concept, is that h max and v naught squared are actually proportional, because 1 over g is a constant, because g is always negative, 9.81 or 10, whatever, if you want to do rounding, and depends on where you choose the direction, but it's always the same, on Earth at least. So we have that, and then so if v naught was sure, so here's just showing proportionality. So if v naught was 2 times as much, then then your h max prime, or your the h max calculated with the v naught that's 2 times as much, would be this, and then this simplifies down to this, and then as you can see above, c v naught squared is also h max. So h max prime is equal to 4 h max. So input 2 get increased by 2 squared. So in general, what does this mean, right? In general, then if x is equal to a times y to the b, or x is proportional to y to the b, then multiplying y by c will multiply x by c to the b. As shown above, we multiply by 2, so it's 2 squared, because this is squared. So x prime equals a times cy to the b here, and then we distribute that. And here, therefore, x prime equals c to the b times x, and this is because, what is it, ay to the b is the same as x. So if we get rid of these two, then it's just c to the b times x. So that's where it comes from. And then finally, how much time until it returns to the ground? Well, we've got this, the position equals, or got this formula because our initial position is 0. So we factor out the t, and so t could either be 0, as you can see here. The 0 is the parabola. Either it could be 0, or if we solve it, then t could be this, which is -4, and here I just visually showed it. So yeah, that's what I've been doing today. I'm gonna have to read another chapter or not a chapter, but a couple pages in the physics book, and also there's another lesson that I have to write down, and hopefully do some math, do some piano practice, because I have piano class tomorrow, and that's about it.